Greetings and welcome to GILFORD'S lectures. So today we are going to be looking at the question 25 of the Nahpi 2021 entrance examination question. That is the physics section of the entrance examination question. And the question 25 reads, a lump of clay whose rest mass is 4 kilograms is traveling at 3 feet the speed of light when it collides head-on with an identical lump going in the opposite direction at the same speed. If the two lumps stick together and no energy is radiated away, what is the mass of the composite lump? So you are given options A, B, C, and D. Effectively, to solve any physics problem, you first of all start by reading the problem and then taking out the important information in this problem before you move into applying physics formulas to get an appropriate solution. Let us read the problem again. A lump of clay whose rest mass is 4 kilograms. So they have given you a rest mass. But what do you even notice about the mass? They are specifying that is a rest mass. That already notifies you of relativity. But if you still do not notice, you just continue reading and you are obviously going to notice. So it's traveling at 3 feet the speed of light. Wow! A lump of clay is traveling at 3 feet the speed of light. Oh, this now makes you to be sure that you are going to use the principle of relativity here. Remember, for Newtonian mechanics, you study the motion of objects traveling at a velocity far less than the speed of light. When objects are already traveling at the speed of light or greater than the speed of light, then you must apply the principle of relativity to analyze the motion. So when it collides head-on with the identical lump going the opposite direction at the same speed, so it collides head-on, so this is a head-on collision, and this collision is with an identical lump going the opposite direction at the same speed. So the very first thing to note is that the collision is a head-on collision. That is, both particles collide and move along the line joining their centers. So that's the meaning of a head-on collision. And when they say the lump is identical, therefore means that the lump has the same mass as the clay. It therefore means that the other body has the same mass as the lump of clay and is going in the opposite direction at the same speed. Since the speed is the same, then it's also 3 feet the speed of light, but it is negative since it is going in the opposite direction to the initial direction, which we are going to consider to be positive. If the two lumps stick together and no energy is radiated away, so the two lumps stick together after collision. So after collision, they stick together and no energy is radiated away. What is the mass of the composite lump? So the next thing you want to notice here is that we're told that no energy is radiated away. When you are told that energy is not radiated away in a collision where the particles move at a speed equal to or greater than the speed of light, then you want to apply the principle of relativity, and more specifically the relativistic energy equation that says that the relativistic energy is always equal to the rest energy. So let us read this keenly, because relativity is a topic that is not done in the advanced level. So it's important for you to know how relativity questions look like and how you can analyze them. So let us read this together. You see that the particles move with a speed greater than the speed of light. Oh wow, there's a surprise emoji here. So anytime you see a problem with particles moving at a speed equal to or greater than the speed of light, then you don't want to apply Newtonian mechanics. You want to first of all apply quantum mechanics, more specifically the principle of relativity. So we can't apply Newtonian mechanics in solving such a problem. We rather apply quantum mechanics. So in a broad sense, mechanics can always be divided into Newtonian mechanics and quantum mechanics. More specifically, relativity. So in this question, we want to apply quantum mechanics, more specifically the principle of relativity. Actually, when bodies move with a speed greater than or equal to the speed of light, their masses due to motion is greater than their rest masses. So if you were having the answer 8 kg in mind, you are totally wrong. Since both bodies were initially moving with a mass of 4 kilograms, you may have the answer 8 kg in mind. since they stick together after collision. Know from today that relativistic mass in the special theory of relativity is a mass that is assigned to a body in motion. In physical theories, that is classical physics, prior to special relativity, the momentum P and energy E, so let us call this capital E, assigned to a body of rest mass m0 and velocity v were given by the formula P is equals to m0v and E is equals to E0 plus m0v squared on 2, where the value of the rest energy E0 was undetermined. In special relativity, the relativistic mass is given by m equals the gamma factor multiplied by m0, where gamma is equals to 1 all over the square root of 1 minus v squared on c squared, and c is the speed of light in a vacuum. So remember we said that when a body is moving at a speed equal to or greater than the speed of light, its mass due to motion is greater than its rest mass. So initially, if a particle is having a rest mass m0, then there's an energy associated to this mass, and that energy is also known as the rest energy E0, which is equals to m0 c squared. But when that body starts moving at the speed of light, then the rest energy changes to a relativistic energy due to a change in mass. So we have the relativistic energy to be equals to the relativistic mass times c squared. It's important for you to note that the relativistic mass is equal to the gamma factor multiplied by the rest mass. Hence, the relativistic energy is equal to the gamma factor multiplied by m0 multiplied by c squared. So this is the formula for the relativistic energy, and this is the formula for the rest energy. So it's also important for you to note that the gamma factor is calculated as 1 on the square root of 1 minus v squared on c squared. With that in mind, it's important to know that when no energy is radiated away, it means energy is conserved. Remember, in the question you have been told that no energy is radiated away. So energy is being conserved, and from the relativistic conservation equation, the relativistic energy of A plus the relativistic energy of B is equal to the rest energy of A and B. Clearly, you see that the relativistic energy of A is given by this relation, that of B is given by this relation, and the rest energy of A and B is given by this relation. It's important to note that M, so this M here is equals to the mass of A plus the mass of B. So the composite lump has mass M and is actually the sum of the masses of A and B. But these masses are not the initial 4 kilograms we're being told of. So they are not the initial 4 kilograms we're being told of. The masses, or this mass, is going to change because these particles are moving with a speed greater than the speed of light. So you notice already in this equation that c squared and this c squared and this c squared all cancel out. So MA is equal to MB. MA is equal to MB and is equal to the rest mass of MA and MB, and it was given to in the equation as 4 kilograms. The magnitude of the velocity of A is also equal to the magnitude of the velocity of B, and was given as 3 feet the speed of light c. So we want to determine the gamma factor, and for you to do that, you must be able to use this formula. So this here is actually squared. So this is v squared, or view this as v squared and c squared. So when you replace v in this formula for 3 feet c, then you are going to obtain gamma to be 5 on 4. So when you do that, the gamma factor of A equals the gamma factor of B and is equal to gamma and is equal to 5 on 4. So from the relativistic energy equation, I said already that this c squared cancels this c squared, which cancels this, and gamma A is equal to gamma B, MA is equals to MB, and so we are going to have M to be equals to 2 gamma M0. So that is going to give us 2 into gamma, remember, was 5 and 4, and M0 was 4. So this 4 cancels this 4, and you are left with 2 times 5, which is 10 kilograms. So you discover that the mass of the composite lump M is actually 10, and it is not 8 kilograms. So that's a very important thing to take note of. When bodies are already moving with a speed v greater than or equal to the speed of light c, then the mass due to motion obviously increases. So there's an increase in mass. So it's important for you to take note of that, solving these problems generally.